Here are the solutions to this week's collaborative problem set. So we have given a table, a two-way table, and asked to find some probabilities, and we know that we need to be careful and on the lookout for the words given that. Notice that here, for the first problems, we don't see the word given that, and so we know that the denominator for all of these problems is going to be 500. So automatically, we can go ahead and fill that in, and again, we know that that's true because we don't see the words given that in the problem. But later on, when we see the words given that, our denominator is going to change. Okay, so let's go ahead and find the numerators, the tops for these fractions. For the first one, the person is a college grad. So reading this table, the total of college grads is 250. So that would be 250 out of 500. And again, we usually like to write these as percentages because most of us don't like fractions. And so that one would be 50%. For the next one, it's took a vacation. So yes to the question that took a vacation, that total is 335. So that would be 335 people out of 500, and if we change that to a percentage, that would be about 67%. For the next one, again, we don't see the words given that, and so our denominator is 500. We need to find the college grads who took a vacation. College grads who took a vacation, oh, there's 200 of them. So that's going to be 200 out of 500, or in other words, 40%. Finally, the person is a college grad or they took a vacation. And again, I think the easiest way to do this is ignore the total columns, because if you use the total columns, you're going to get messed up often. And let's just look at our data. And what I'm going to do is I'm going to circle the groups that are either college grads or they took a vacation. So here we have our college grads. Oh, and these people took a vacation. So we have to add together 200 plus 50 plus 135. So if we take 200 plus 50 plus 135, we get 385 people. So that's 385 people. And again, making that into a percentage, that would be about 77%. All right, so now let's look at these ones that use the words given that. All right, so when you see the words given that, what it means is that when you look at your data, you are going to ignore everyone except the group that were given. Given that they took a vacation, so I'm only going to look at the people who took a vacation. These are the people that took a vacation. And notice that there's 335 of them. And so that's our denominator. Of those, how many are college grads? 200. And so to find that answer, we have 200 out of 335, or about 59.7%. For the next one, we want they're a college grad. So now I'm going to only look at the college grads, and I'm going to ignore everyone else in the table. So notice that there are 250 in that group. And of those, I want to find how many took a vacation. So of those, 200 took a vacation. So again, if we change that into a percentage, 200 divided by 250 is 80%. And so that's a recap on probabilities with two-way tables. Okay, so for F, it says which group is more likely to have taken a vacation, college grads or non-college grads? Support your answer with appropriate statistics. Okay, so of the college grads, if we only look at the college grads, there's 250 of them. and 200 took a vacation. So of the non-college grads, non-college, there are 250, so similar denominator, same denominator, and of those, only 135 took a vacation. And so you could change these into percentages, but you'll see that this one is greater. All right. For number 2, give an example of a discrete random variable. And for number 3, give an example of a continuous random variable. So remember, the difference between those are discrete random variables can only have values that look like this, 0, 1, 2, 3. In other words, it's impossible for the value of the variable to be a decimal or a fraction. Okay? For a continuous random variable, the variable can be a decimal or a fraction. Another way of thinking about that is it continuously grows, just like the number line. The value can be any number along the number line. So examples of continuous functions are weight, height, time, distance. These are some common examples of continuous random variables, because if you think of any of those variables, all of those could have fraction or decimal values. Finally, let's take a look at the last problem here. It starts up here. Sorry for the weird paging. But products on Amazon are given star ratings, and so you were given a probability distribution with a number missing, and you were asked to find that missing number. But remember that the sum, meaning if you add, of all the probabilities has to equal 1. And so if you add up all of these probabilities that you're given, these probabilities all add up to 0.88. And so by subtracting, you can find out that this missing number would be 0.12. And finally, use this probability distribution to find the probability that someone gave a book a 3 or a 4-star rating. Here are the 3 and 4-star ratings. And so that would be 0.32 plus 0.35, or in other words, 0.67. Don't hesitate to email me if you have any questions about that problem set, but those are the solutions.